Hi Advanced Maths, I'm about to do for you 7.8, which is about the perpendicular distance formula. Okay, this is the hardest topic that we have here in Advanced Maths for linear relationships, but it's not too difficult. I'm not going to prove it to you, you don't need to know how to prove it, it's quite difficult to prove, so I'm not going to confuse you with that, but you do know how to you do need to know how to use this equation. Alright, so how this equation, what it's actually talking about, here's our Cartesian plane here, y, x, and our origin, okay, is that if we have a line, say this line here, maybe this line is y equals minus x plus 1, that's our line, okay, and maybe we have another point over here in the distance. What they want to know is how far is this point, x1, y1, how far is this point from this line at the shortest distance? You know that the shortest distance is going to be the perpendicular distance, because here we go, that's the perpendicular distance. This is obviously going to be longer. It's if you draw a circle, obviously the perpendicular distance is going to be the shortest distance. Okay, so we want to know the shortest distance from this point here, x1, y1, to the line y equals minus x plus 1, or any line. The first thing that we need to do to be able to use our perpendicular distance formula is to put this into the general form. The general form means 0 equals, first of all we do the x's, minus x, then we do the y's, minus y, then we do the constant, plus 1. Okay, so that is our general formula. So general formula first of all, in general form, sorry, general form. Okay, once we've got our general form, whatever's in front of the x, that's A. Whatever's in front of the y, that's B. And whatever the constant is C. Now the easy way to remember this is x comes before y, a comes before b, and c equals constant. Okay, so c, constant, alright, and that's how you make that make sense. Okay, so we got that in our general form. Then we need to write down that our x1 equals whatever this is. So say this is point, let's say that could be 3, 3. So how far away by perpendicular is 3, 3 from that line? Okay, so x1 equals 3, y1 equals 3. Then we simply plug all of these things into this formula here, which is the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. That's our formula, okay? So in the case of this one here, we would be doing a absolute value of minus 1 times by 3 plus minus 1 times by 3 plus 1. That's our constant there. That's all absolute valued. All over a squared, which is 9, plus b squared, which is 9. Okay, so the final distance formula here, the distance, perpendicular distance from 3, 3 to this line here, is going to be minus 3 plus 1 over root 18, okay, which is minus 5, which is 5 over root 18. Okay, now we could also rationalize the denominator, 5 root 18 over 18, if you like that a bit better. Okay, so that is our perpendicular distance. Oh, of course, we can simplify this. Okay, let's turn this root 18, we can take out 9, so it becomes 15 root 2 over 18. We can divide this top and bottom by 3, 5 root 2 over 6. Alright, so anyway, that's our perpendicular distance formula, so we need to learn what that is. It's pretty easy to learn. You just a squared, b squared, that's a bit like the triangle formula, ax plus by plus c. Okay, that's all pretty easy. So you can remember that pretty easily, and then we just need to know how to plug it in, how to use it properly. We've got to get the general form. We've got to remember our a, our b, and our constant. Okay, this could be a number here, not just -1. Okay, and that's what we're finding. We're finding in the end this distance here. What is the distance there? Okay, so that's the perpendicular distance formula. Hope that makes sense. That's actually the end of chapter 7 for advanced people. So good luck, well done, and good luck again. Yeah. Okay. Bye bye.